So in my previous video, I set you out 3 questions to look at for calculating the solutions to equations using the quadratic formula. What I'm going to do in this video is I'm going to show you how these solutions should have looked and the working you should lay out. But just a quick refresher, these were the 3 questions I asked you to do. So calculate the root to 1 decimal place of the following 3 functions. So first one was 6x squared plus x minus 7 equals 0. B was 2x squared minus 7x minus 11 equals 0. And C was x bracket 3x minus 1 equals 7. So let's have a look at the 3 of these. So the first one was 6x squared plus x minus 7 equals 0. So I want to solve that using the quadratic formula and find the roots. First thing you should do is think to yourself, right, what was the quadratic formula again? Well, if we think back and remember it, we know it was x equals negative b plus or minus the square root of b squared minus 4ac all over the value of 2a. So this was the formula we had to use, not only in this one, but the other examples we're going to look at later on. First thing we have to do for this is identify what a, b and c are with respect to the quadratic. Now remember, a, b and c are the coefficients of our squared term, our singular power term and our constant respectively. So a comes from there, b comes from there, and c comes from there. And remember, we have to take the signs with them. So in this case, a is 6, b is 1, and c is negative 7. Once you've identified them, you can just simply substitute them in. So in this case, x equals negative b, so negative 1, plus or minus the square root, b squared, so 1 squared, minus 4 times a, which is 6, times c, which is negative 7, all divided by the coefficient 2 times a, which in this case is 2 times 6. So we then start to work this through and simplify it. So we get negative 1 plus or minus the square root, well 1 squared is just 1, take away 4 times 6 times negative 7 gives you negative 168, all over 2 sixes, which is 12. 1 minus minus 168, minus minus becomes a plus, so I get negative 1 plus or minus the square root of 169 over 12. Now the nice thing about this is, root of 169 is 13. So we get negative 1 plus or minus 13 divided by 12. Now, I did say it could help us calculate more complex ones. I never said it couldn't help us calculate more straightforward ones. So it does allow us to do this as well. So what we can do is take this and we get our 2 roots from it. So what we do is we say, right, so x equals negative 1 plus 13 over 12, or x equals negative 1 minus 13 over 12. So negative 1 plus 13 is 12 over 12, which is 1. Or for the second one, negative 1 minus 13 is negative 14 over 12, gives me negative 7 over 6. So there's my 2 solutions for that one. Great, it helps me find it when I know what the root is and it works out to a normal number, so a number without much decimal work. However, it can also help us to get ones where the decimals come into play more frequently and often. So let's imagine I've got 2x squared minus 7x minus 11 equals 0, and I want to find the roots to that one. Again, our first step is we have to identify the a, the b and the c to use in our quadratic formula. So in this case, a is equal to 2, b is equal to negative 7, remember to take the signs with it, and c is equal to negative 11. From that, we then plug everything into the formula we've got for our quadratic formula. So we know in this case x equals negative b, so negative negative becomes a positive, plus or minus the square root of b squared, so negative 7 squared, minus 4 times a, which is 2, times c, which is negative 11. And that's all over the value of 2a, which is 2 times 2. Start to simplify this out and work it down. 7 plus or minus the square root, well, negative 7 squared is 49. Take away 4 times 2 times negative 11, that gives me negative 88. All divided by 4. Simplify this up, and I get 7 plus or minus the square root. 49 minus minus, minus minus becomes a plus. 88 gives me 137, all over 4. So from that, I can just simply start to read off my 2 roots. I've got 7 plus the square root of 137 over 4. Or I've got 7 minus the square root of 137 over 4. We've got to remember we have to take both of these into account. Okay, roots of a function of quadratic tend to be two places, unless it's a singular repeated root. In these sorts of questions, though, you'll find more often than not, 99% of the time, they'll be testing your skills to make sure you remember there's two possible roots. At this point, this is where your calculator comes in handy. So just plug it in. So the plus 1, so 7 plus root 137 over 4, what that ends up giving you is 4.6761 and a whole spiel of stuff. Or this one here with the subtract gives me negative 1.17617 and again a whole spiel of stuff. Key thing here is make sure you include a few decimal places. You've got to show you're rounding it properly. And I know it said to round it to one decimal place. You have to show it you're taking a number and rounding it accurately. You can't just write down the final answer for this. You have to show them unrounded, then round it. So in this case, rounding this to one decimal place gives me 4.7. Or for the second one, negative 1.2. There you go, I've got my two roots, both to one decimal place. Like I said, this is a key point here. This can cost you marks if you don't put an unrounded version in. So show them you know what you're doing. Show them that you know, I'm taking this unrounded version. I know how to round these things, and I know how to solve. Last one I wanted to look at was one that was written like this. Now this isn't in standard quadratic form. Remember, it has to be ax squared plus bx plus c equals 0 for us to be able to do it. So when you get one like this, it's not like that. Manipulate it and make it like that. So to start, I'd multiply out the brackets. I'd get 3x squared minus x equals 7. Then rearrange it to get 3x squared minus x minus 7 equals 0. Now it's in standard quadratic form. Now I can jump straight into my formula. So I know I can get my a, my b, and my c from that. So a, in this case, is 3, b is negative 1, and c is negative 7. And now I can stick it all in my formula. So I know that in this case, x equals negative b, 1, plus or minus the square root of b squared, so negative 1 squared, take away 4, ac, so 4 times 3 times the negative 7. And that's all then divided by 2a, so in this case it's divided by 2 times 3. Then we just start working it through. So we get 1 plus or minus the square root, well, negative 1 squared is 1, take away negative 84, 4 times 3 times 7, and divide that by 6. So now that then is going to equal 1 plus or minus the square root of 85 over 6. There's my two answers from the plus and the minus version of it. So what I can then do is separate them up, get my two roots, and take it from there. So I know then x equals 1 plus the square root of 85 over 6, or 1 minus the square root of 85 over 6. Plug it in a calculator and get your answers. Remember, you always write the unrounded version first. So x equals 2.5548, and then a spiel of stuff for the positive one. Or for when I subtract, I get x equal to negative 2.054, and again a whole spiel of stuff. Now I can round them. Now I know that I've shown unrounded version. We'll then round to this. I do it. 2.55848. That rounds to 2.6. Negative 2.054 rounds to negative 2.1. And I've got my two answers. I've got my two roots for the equation. Ones like this, these are the general steps you have to follow. First, you have to make sure it's in the out form. You need to a, b, and c from that. Plug them into the formula, manipulate it, and work it through. Hope they went well for you. Good luck with the work for the textbook.